Okay, take number 1. So what are we looking at today? This is a almost completed supervisor circuit that is used to measure the health and stability of a audio amplifier, specifically a Class D audio amplifier. What this circuit does is a bunch of really interesting things. Firstly, as shown on the LCD there, it has the capability of monitoring and measuring the temperature and fan for a single temperature sensor over there. And when that temperature sensor detects that the threshold conditions is exceeded, the fan will spin faster and faster. So I'm going to show a quick demo of that behavior. I'll take my soldering iron over here, which is heated at approximately 300 degrees Celsius, and I'm going to attempt to heat up the sensor slightly just to trigger a trip condition. Also notice how the temperature on the LCD shows a change in temperature. So before we attempt to heat up this node, this temperature sensor node, the set points are anything, I think, under 30 degrees Celsius gets a PWM of 70%, 77%. Anything over 30 degrees and under 40 gets a 80% PWM, and anything above 50 degrees will get a 90%. Not sure what the numbers are there, but we'll see. So let's quickly just get that temperature to increase. Okay, there we go, 30. There we go. $35, $40. There we go. So the rules basically for the first condition is when the temperature hits what looks like 42 degrees Celsius, the PWM will basically run for approximately 1 minute. Okay. So the new PWM will be sustained for approximately 1 minute. We're just going to wait until that. There's still some flickering on the LCD. I'm not sure what that is about. There we go. 1 minute complete. So the next test is we will introduce a trip at over 40 degrees Celsius. So let's do that. So firstly, I deliberately did the 40 degrees Celsius trip, but I want to exceed that whilst the current condition is running, which is the range between 30 and 40, and I'll set it all the way up to 50. Check the PWM. Look at that. So now temperature has exceeded 50 degrees, and the PWM will sustain at 97% for 5 minutes. So basically, what's happening here is the evaluation condition for situations where a change in temperature condition keeps exceeding the previous state, gets reevaluated, turning the fan on or forcing the PWM further to a point where it has now maximized its worst case scenario condition. You can see that got quite a interesting brand of fan here. I think this is a Cooler Master, one of these silent fan brands. Quite good quality, a little bit more expensive than the standard fans that you'll find. And this is a computer 4-wire fan. A little bit about the circuit. We've got here a quick prototype board, basically with a potential divider that basically reduces the tacho output, which is a 12 volt tacho output, to something suitable like 12 volt. Now there's also a little capacitor over there, 10 nano farad, just used to clip the noise on that line, because it's going into a capture pin that's used to measure the frequency. You've also got a little transistor there that is used to force the output of the signal to a low that will indicate the RPM output. Okay, you can see we're still running at 97% PWM at 24 degrees Celsius. Here is our fan sensor. It's right over there. I can force it here just to see if it actually influences the temperature further. I think it should bring it also slightly down. And there we go. We've basically reached our 5-minute sustained PWM interval, and we're back at our 77% mark, which is our minimum or normal RPM. That will allow the amplifier to have slight cooling, but just enough to keep the noise down. If any conditions in temperature changes, a reevaluation of the temperature will take place. So that's our first feature completed. So yeah, cool. Thank you very much.